Grant and Jared, so nice to see you. Welcome. So thank you much for joining us. And Rich, you'll be interested to know that both Ray, who we were just with, and Grant and Jared are all Albertans.
Yeah, we have a sunny disposition.
Great blue Alberta sky.
Yes, exactly.
Yeah.
It's a blue sky day.
Welcome to the Darby Mills series, Intrepid Pioneers of the Next Economy, featuring discussions with entrepreneurs at the forefront of deploying machine intelligence and brainstorming sessions about where the technology may go at the limit.
Welcome to the Darby Mills series, Intrepid Pioneers of the Next Economy. I'm Ajay Agrawal and co-founder at Intrepid Growth Partners, and I'm here with our hosts, Rich Sutton at the University of Alberta, who pioneered reinforcement learning, Sendhil Mullainathan of MIT, who uses machine learning to understand complex problems in human behavior, and Niamh Gavin, an applied AI scientist working on optimizing open and closed foundation models for novel semiconductors. In the Darby Mills series, Rich, Sendhil, and Niamh meet with pioneers at the forefront of deploying machine intelligence and brainstorm on where this will go at the limit. What is the trajectory for machine intelligence in each of these domains, and how might we get there? So in today's show, I'm delighted to introduce Grant Sanden and Jared Deutsch of GeologicAI. Grant is the president and CEO, and Jared is president of RMS. Geologic aims to optimize productivity in geologic exploration and mining operations based on core sample analysis. And this company really informs a wide range of questions. The first one is by taking a core sample, or a handful of core samples, which are expensive. So in other words, the data collection process here is very expensive relative to many applications that most people are used to thinking about, to predict, first of all, whether to build a mine or not. So that can be a 5 to sometimes a $30 billion decision. And so that's a sort of a binary, should we build or not build? Then once a mine is built, every year they make a decision of whether to expand the mine in terms of their annual budgeting. And so that's also predicated on sampling some data and making a decision of whether to further expand a mine. And then there's a more regular daily decision on how to operate. And so, in other words, just the mining operation processes that are continual and made on a daily basis. And so I think a useful mental model for people as they're thinking about this business is, the traditional way people do this is they will be at a mine site and take a core sample, and traditionally they'll take that core sample, they might ship it somewhere, and then geologists will stare at that, and they will, and these are people with years of university training and then on-the-job experience, to log what they see. So they'll stare at this core sample, and inch by inch they'll go down the core sample and log what they see and write it down. In their expert opinion, this is what they think it is. And then they pass that log data to a different set of people who then use it to make predictions, like, for example, how big are the mineral deposits under the ground, how hard will it be to get them out, how much is it worth. And so the company that we are talking to today, when they pull that core sample out of the ground, rather than shipping it off for people to study, they put it into a contraption that they've created, where they have high fidelity cameras and lasers and hyperspectral image data that they take from the core samples, and that data is given to an AI whose job is to predict what it's seeing. And so they've automated the logging data process. And then the way you can think about this is then they hand that automated data over to another AI that does the predictions of, okay, given that that's what's in this core sample, what does the deposit under the ground look like? And then that enables a subsequent prediction leading to an action. For example, where could I take the next core sample to most reduce the confidence intervals in my prediction? Jared or Grant, anything you'd like to add before we just start discussing that?
Yeah, some interesting aspects of this new type of data collection is the harmonization of this data across sites and instrumentation, and then the collection of the metadata that you need to compare instrument to instrument, and also to advance what you're collecting at the same time you're trying to deploy results. So you've got this information flow from this new machinery giving you secondary information at a high scale, and then the question is, you've also got the information coming in from the geologists who are predicting what the rock is. And then there's all these comparator exercises as to improve initial prediction, but then move it into modeling, which incorporates all the other data of the site. And so you've got different data flows. You've got challenges in mining. You're only touching a trillionth of the deposit. And so there's some uniqueness as to how that flows. And it really is a structural problem in prediction, is dealing with the trillionth. But then once you can deal with that well, you're now characterizing uncertainty. And with these new tools, we can plan through more robustly with uncertainty properly quantified, which is a challenging endeavor. Jared, any comments?
Yeah, absolutely. I mean, I love the application of AI in mining is so unique because we're so data poor spatially, but so data rich thanks to scanning and many other technologies where we have millimeter scale data. Challenges we're 100 meters away from our next millimeter scale data. So this makes for a very challenging problem in a very non-stationary environment where no mineral deposit is like another one. And we can't really afford to sit around for a few 100 million years and wait to see how these things evolve. So it makes for a really fun and exciting application of AI, but a bit unique compared to other areas.
Excellent. Thanks, Grant and Jared. Sendhil, anything on your side to get started on that?
Yeah, a couple of things. First, I think Jared and Grant, if I can give you some friendly advice, I think you should enter a different business of selling non-blue shirts to men. I think if this is any sign, there's a huge demand in that market. I don't know what's going on anyway. But putting that aside, I assume you'll stay in geology. I had a couple of questions that I think I just found super interesting what you're doing. And the main question I had was, there must be a huge element of human algorithm interaction here. I think, Grant, you mentioned the geologist predictions enter the data pipeline. I don't know if the algorithm is using that. There must also just be an element of persuasion at the other end. Whatever the algorithm produces needs to somehow have a persuasive element. And there must also be a potential for the geologists themselves to learn from whatever the algorithm is doing. So anything in that space, I would just love to hear how that all plays itself out, how you think about it, how you manage that component, how that enters your technical build, or do you view that as a separate activity independent of the technical build?
Well, I think there's a fascinating approach to this. So from a business perspective, we had to build a model that was a system of gathering data around the world that was profitable and would improve. And so you can approach it from hey, I need the perfect data set, which is frankly impossible and of a massive scale, or you can approach it from, we're going to collect data and use it for its local insight that's valuable enough to have customers start consuming it, and then build a system that improves. And I always call it, where it gets really interesting is you can go to a 100-year-old mine site and you can have AI predicting, is this rock A or rock B? And what we do is we publish a confidence factor. And then the human goes in and says, okay, if it's under whatever X% confidence, I look at this and I decide what I think it is. And then we try to improve the model. And if you can't improve the model, chances are your differentiation between rock A and B is either incorrect or needs some refinement. And so you can elevate that whole thinking of what the actual types of rock in the deposit are. And what tends to fall out of that is really interesting things like this type of rock has most of our arsenic in it, and we've now identified it because we were trying to predict it, and we were forced to recategorize our prediction based on this super consistent, precise engine that's running beside us. And so that's where it gets really interesting, because that then foundationally changes the geological interpretation of the deposit. And not necessarily foundationally, but enough that you can clearly see the patterns emerging. And that's one thing about geoscience. There's a bit of a beauty contest element to it. If you can identify something new or identify a new mineral that is a tracer element to what you're going for, it gets really interesting on the edges.
Grant, can I just follow up? Because I just want to make sure I got the story. That seems like a super important story to understand for your entire business. You're sort of saying, rather than the algorithm coming in and saying, look, I've made my prediction, here's the prediction, you're entering at a more granular level in workflow and saying, look, you as a geologist are in the business of identifying these things. Let us just semi-automate that for you, which you're happy to have do. Then they come in and they see these edge cases, But those edge cases then draw them like, wait, why is this thing always coming in an edge case? Oh, I learned something from this edge case. So there's sort of insight being had already, partly because you didn't come in at the top of the funnel. You came in kind of at the bottom at what looked to be an automation activity, but it was kind of an automation activity that became an interesting discovery activity. I just want to make sure I got the story right.
Yeah, that nailed it. So you have this data flow from the interpreters, and they're putting it against a prediction. And that prediction might be great, it might be okay, but the art of doing that leads you to all the edge cases being way more interesting, and then helps you refine the problem on a holistic level, if that makes sense.
Yes, sorry, Grant, can I ask, to what extent was that defined in advance versus in response to user adoption? And what I mean by that is this resonates a lot with my background is kind of in healthcare or AI for scientific discovery. One of the best use cases for that initially was things like pathology, where you could use AI to kind of scan the image and look for tumors in cancer or something like that. But we needed the experts, the specialists, to annotate it and ensure it was correct. But there was zero incentive to do it because it's turkeys voting for Christmas, because they just feel their careers are going to be automated away by this AI. So if anything, they probably fudge the system to make it fail.
And that was the approach to market, was there certain outputs we could generate from, say, hyperspectral that are immediately valuable to the users. And so there's very simple things you can do, like this is the absorption of light at 2200 nanometers, and that helps me distinguish crystallography or something. By doing that, we get them to adopt the software and make predictions in software. And then we can do all those cross comparators later. So it's what small task can you achieve that's immediately valuable, that allows you to go after the larger scale value, which is a system of information that's improving with human interpretation.
This seems like what you guys are doing is just such a clever way to think about algorithms and humans interacting. It's sort of saying, let me bring in something that has immediate value to you, but by using it, it will reveal to you some of the places where you don't understand things as well as you thought you did. It's very clever, super clever.
I have to confess, I'm still reeling at the incredible significance of each one of your decisions, like where to build a mine, even where to drill the next hole is a big decision. Where to drill a mine, it seems to me it's almost got to be down to a person, because, if you build a mine in the wrong place and it's going to be, you said to build the mine and your company is now in trouble, it seems like you almost need that accountability. So first I'm reeling from the role that automation can play, and I think Sendhil's comments allude to how it actually works in a more subtle way, the interaction between the people and the automation. But still trying to wrap my head around it. And so what is the competitive advantage that an automated system can bring? And maybe it could become like a super geologist because it's seen so many more cores from all around the world. I mean, people are really smart, but they can't see everything, and their lives are finite. And just as an AI system can read everything on the internet, maybe you can see all the cores in the world and see similarities between them that would not be apparent to someone that didn't have so much experience. So that leads me to think you want to get all the cores in the world. And is anything like that, to what extent is that possible or impossible? I guess that's my first question.
So if you look at the market in the world drills every year 130 million meters of core. We launched a system for getting into the large-scale mines, which is a majority of that. So it's not the exploration edges. We've just surpassed 1 million meters, and we'll hit a run rate of 1 million meters by the end of the year. So again, we're just at the early stages, but it's a global operation with a system that has value, and so we're hoping to deploy that and continuously improve on the data and the data methodologies to collect the cores and solve local problems, so like geological problems. But what we're seeing with modeling in the rest of the data, there's that immediate acceleration of information, so you're getting more value from the geological problems. And so then we acquired RMS, Jared's company, because they can solve the problems of the mining company itself, like CEO level problems. when to drill, how to do that. And, there's the general geometry problems of mining that fit well, but there's actually very valuably and immediate is optimization of rock flows through plants. There's just immediate benefit to production and, CO2 emissions of existing massive scale operations where you can just optimize and tailor how these plants run so they run more consistently. And maybe you change how you manage rock.
So then it becomes more like a factory with a sequence of events and smaller decisions that are made. So you guys have both sides of that.
Well, we're just starting on the journey, right? So it's let's build the rock database libraries and let's deploy them to solve the problems at the various levels. But of course, the goal of the organization is to hit at the heart of the most valuable problems.
Can I follow up on Rich's question? Because I just had not thought about it this way until you said it, Rich. It feels like having, I'm going to say the most obvious thing, which is just having a lot of core samples is super valuable to you. And it seems like you're getting a lot in the natural order of things of how data are collected. But I could also imagine saying, yeah, okay, that's fine. We get the data that they're collecting for their purposes. What if we just went out and collected other data just for purposes of building the model? What would that data look like? Are there things you can do, for example, after we've done the mine and we know a lot of stuff, maybe we just go and get more core samples for this thing where we already know what's there. So we get 20 core samples because we have really good ground truth labels. Let's get them from 20 different places or something. Is there a pure data collection strategy that is potentially useful to you that might augment the data that tends to be produced in the natural course of business? Or is that just a kind of a dead end?
We like to view this as kind of a data integration problem. So we've drilled a hole. 10 years from now, we'll build the mine. 20 years from now, we might hit that spot where that core sample pierced through as mining through. And now we have a chance to compare and see how we're doing. So now you're looking at the reconciliation, made these predictions, how is it actually flowing through the plant, and so on. So there is a little bit of a time lag, but as all these mines are operating, we have the chance to observe it at many different points and can pull in that raw data of this is how that rock is flowing through the mill, this is how much the metal we're able to extract, this is how hard it is, how much power it's using, how much CO2 it's emitting, and then integrate that into the model. So you're building a real multi-scale spatial prediction.
Jared, I want to pull through in our last episode when we were talking about chocolate factories. The topic went to the length of learning loops. And you've just described a painfully long loop where you take a sample and then 20 years later you find out if the predictions you were making were correct or not. And so in terms of, and Sendhil was making points in the last episode about things you can do to tighten up and shorten the loop. And so here, Sendhil's asking about what are the cases where the return on investment for collecting more data just for the sake of data that's not part of the natural production process is that data is so valuable that it's worth it to collect the data even when it's not just part of the traditional pre-AI mining exploration process. So one thing you could imagine is you take the core sample, you make the prediction that you're not going to find out if you were right or not until 20 years from now, and tighten it up by the next day you go and take another core sample where you've predicted what you're going to see in that core sample, and then you see if you're right or not.
Yeah, it is absolutely a continuous loop. Like, we won't know the ultimate truth until it's actually mined and processed. But the way that we approach these problems is, okay, you've drilled, you make a prediction. Then when you go and drill your next drill hole designed to reduce your uncertainty as much as possible, you analyze, okay, I had a prediction for where I drilled through. What is my accuracy? What is my precision? Am I introducing a bias or anything like that? So there is that continuous cycle. In the scale of mining, it's pretty fast. This could be weeks to months. So we're able to actually iterate like that. And it's nice because we've been at this a while. There's many mines we've worked with where they've had our predictions integrated, and over the course of years and multiple drilling campaigns, they've been able to see, okay, these do hold together. We can get a better prediction of what's coming down the pipe for us.
So on one hand, and again, this resonates so deeply with pharma for me, because on one hand, Mr. Mining Company, benefit from the fact that you see all the data I don't see, and therefore you get all the insights at scale from that. But on the other hand, I want to be a free rider in that I don't want to give you my IP, my field log data that I've built up over the hundreds of years that these mining companies are, for all my competitors to benefit from as well. So I was just wondering, A, whether you've kind of encountered that and how you address it on the sales side, but then also for us, on the technical side, are you using things like federated learning, or how are you trying to overcome that IP ring fencing whilst getting the metadata from it?
Yeah, so on the sales side, we have elegant solutions for contracting. So what we really drive after is we want to make sure we have freedom to operate on the process for analyzing the data, not the data, because the data is on the customer's side. But there are many situations in industry where it's mutually beneficial to elevate the knowledge base from the data, and we see those arising, and it becomes obvious. And then there's other situations where the data is owned by a regulator, and you have the ability to use proof cases against regulated public data.
Yeah, I think this is just building on the thing you said, Jared. This is more reflecting my just not understanding enough about mining. So, but it builds on Ajay's point, which is if the 20-year lag is the lag, is this what's happening? Like, I've dug really far in, I've gotten something, but it's 20 years before the actual mine gets that far down. So really, we're not going to get a ground truth label. That wasn't a pun. But I literally just, yeah. Anyway, right. You're not going to get a gold standard. Okay, wait, that's happening again. Okay, whatever it is, we're not going to get a label. Do you guys just do this all day? Do you just do like ML, ground truth, gold standard label jokes? Anyway, go all the way down.
Yes.
That's the issue. Okay. Yes, you do. Okay, great. So you go down. You get that 20 years later. I guess if that's what's happening, can you take a mine that's already about to reach a point here and then do a drilling of that now? Because you know you're going to get the data in a month when that mine is about to hit that point. Like, and is that a thing? Like that? I think that was your point, Ajay, about like a collection of a thing. That's a thing where you could have drilled here and waited 20 years, or knowing that you're going to go there now, you might as well drill now and get it, because you're going to get the real label in a minute. Is that a kind of thing that's doable, interesting, or is that just way too expensive because each sample is just so expensive? It's just not worth that hassle.
That's why we engage at all phases of the mine. So we're engaged at deposits that have a 1 in 1,000 shot of becoming a mine in my lifetime. And then we're also engaged at deposits that are actively mining now, and they're scanning it, and then they're mining that within the course of a year or so. So we do get the chance to observe it at the different scales and take learnings from each of those.
And just picking back on that question, because another way to flip it is to almost via kind of Trojan horse entry of, I don't know, coming up with a better drill bit or something such that you're you become vertically integrated. You start with a tool and then you add kind of the A on top of it, such that you're present with every core sample. Have you ever kind of thought about it that way, or partnering with someone?
Where this gets really interesting is if the AI is working at a core level, can it work on a chip level? So it's a lot less expensive to drill and produce chips than it is to produce core, for example. And so it's a chip off a drill bit, as opposed to pulling a tube of rock out. You're just letting the drill go and produce a chip of rock. So like a cutting from the bit, if you will.
Yeah.
And so that's an order of magnitude lower cost to do that collection than core collection. And so if the AI works on a core level, can we transpose it into, call it dust, off drills? And if we can, of course, there's a structural advantage into how the world would explore and develop mines. And so all of this comes with, as part of a larger scale, call it data reconciliation at scale exercise. And that's foundationally what we push towards. I hope I've said that well, Jared.
Yeah, absolutely. And that's where, I mean, one of the really interesting things about mining is when we're making predictions, we're predicting in the context of what mining calls the information effect. That is, we know that we haven't got all the information we're going to have when we make our final prediction and our final decision. So our predictions are somewhat baking in what we think we're going to do when we get there, what other information we're going to collect. So by collecting all this data along multiple layers, we get the opportunity to get better at anticipating that information effect and making high-level decisions at the start and then low-level ones at the end.
I'm going to say that this mining decisions, particularly the placement of the next core, the next place you drill, this is very much like a classic exploration-exploitation trade-off. It's somewhat expensive. The cycle is not really 20 years. It's like this drill, you drilled a set of holes, and the next season you're going to drill a different set of holes. And where are those next holes going to be? I mean, if it was really automated, you could decide it on a hole-by-hole basis. That would be good and it's perfectly feasible. But then it's like a bandit problem. You drill a hole. Oh, I found gold here. I didn't find gold here. And basically, when you drill a good hole, you don't have to wait 20 years. That was a great place to drill that hole because you discovered something that was important. Even if you've discovered that there is no gold there, that discovery is really valuable. So that's the time cycle.
Absolutely, and that's one of the things we seek to optimize is just how much data should you go out and collect? How certain do you need to be? Given that you're going to collect more information by the time you dig down there, how much information do you really need? And that's where this all comes together, the automation, the AI, everything. I
would imagine as you're finding some good deposits, that's a success, but now you're trying to make the decision, should I build the mine? For that, you need to know how big it is, and you need a higher level of certainty. So you're going to, as you say, when do I decide to stop? I found a good deposit here, and I could drill cores on it all season, but I really need to decide whether to build a mine. And a mine is so expensive and so rare. You've got to be higher certainty, but you don't want to be over certain. You don't want to waste money drilling when you've already made up your mind. It's like, I think of a graduate student. We have to make a decision about whether this graduate student stays in the program or not. We could ask more questions, but do we have enough to know? We know we should allow them to go forward. We know we should build this mine.
Oh, giving me flashbacks.
So Rich, if you were to imagine the mine of the future, let's say or the exploration, let's focus on that part, that's fully automated. And so it's the meta level decision is a return on investment decision, an ROI optimization problem. And so there's some robot running around the surface of the earth and it's poking holes in. And it's deciding each time, and holes are expensive. So there's cost. Every time you grab a data point, it's expensive.
But there are choices. You could do a chip or you could do a hole.
Right. And
you could do a core.
And so the chips are much cheaper, but they reveal less information. And
and there are other things you can do. You can fly a plane over the territory and do radar and do some kind of imaging, various kinds of imaging. I'm sure I don't know anything about it, but these things happen. Your robot could be a drone flying all over the world and generating prospects.
Right.
Absolutely.
And I'd just like to point out the one assumption we make with this, because it chimes back to the kind of the ag tech phase where everyone was coming up with IoT sensors in the ground for real time, precision, for you only need to put fertilizer on this one plant, and they did all the work, and then they went out to the Midland America and realized there's no Wi-Fi. And it's a similar thing here, I think, in terms of, I imagine a lot of the deposits are in the most remote parts of the world, and so you probably use mesh networking or something like that to try and do your analytics, but that might be kind of a simple, there's no electricity discovery at the end of our automated mine.
And I'm trying to link back to the last discussion on the chocolate factory of these sort of hierarchy of decisions and loops. And so here, there's a decision of where's the next best hole to drill or chip to collect or aerial image to collect in order to drive a subsequent action. And then the point that Sendhil made also in the last time about, the actions then generate data that are going to inform the next prediction.
And the next action.
Action. And so the extent to which, as you're thinking about that, the transition from where we are today to that fully automated scenario, notwithstanding Niamh's point of those types of limitations, what would you see? And maybe Rich, you can take this one first. Is just in terms of the optimal path from going from these very limited loops to the ultimate loop. How do you think about the optimal method of getting there?
I don't know, but I'm actually pretty sure the way we get there will not be optimal.
No, I think this is just so fantastic. I did not expect to find geology this interesting. So rocks are more interesting than chocolate is what I'm learning the last two interactions.
When they're formed over billions to millions of years and you're trying to figure out how that happened and where to go to get it out, it makes for some really fun AI challenges.
And Niamh, anything on your side?
No, I think it's perfect timing, just given kind of the geopolitical landscape as well, and things like rare earth elements and all the trends around EVs. I'm sure there'll be greater adoption of your technology in countries where there aren't traditionally mines for that kind of political security, sovereignty reason as well. So good timing.
Yep. And Rich, anything on your side? Just closing comments on this exercise for mining.
It's turned out to be an amazingly rich and diverse set of possibilities. I guess that's maybe not good for clarifying which should be taken first. The diverse choices I think I'm speaking of are in the total exploration, greenfield exploration, and how that those possibilities, and the idea of having a super geologist that is expert in almost the entire Earth, all the places that people have drilled holes before. That's another anchor point to try that might be the best path that Ajay was referring to, or it could be that the best path is in operations in Jared's area, where you have the tightest loops. You make a decision now, and you can see how much ore you're getting out, or what kind of quality of the ore you're getting out. Those are really tight feedback loops, and they also involve things, just logistical things like how expensive is it turning out to be, and those I think that should be pursued, because if it works out, it'll be close and it will be nearer term. And I think all three of these are intriguing. The operations, the universal geologist expert, and the mega explorer. Thank you for telling us about them today and about these innovative ideas you have, ways of approaching these challenges. It's really interesting and big, as Sendhil was acknowledging a moment ago.
Great. Thanks, Rich. And Sendhil, last thing, a question for you, which is, in the last episode you talked about maybe choosing factories that had the types of properties that would best exploit that style of learning and automation. If you were to go here, because you opened with a line of questioning around what about collecting data for data's sake as opposed to the process, and you could imagine collecting data from similar mines because you want to create as broad a data set on similar types of formations and so on, or to specifically seek out mine sites where you get more variation in the data that have different. Is there any kind of approach that your intuition is guiding you towards in terms of the optimizing the data variation path?
Yeah, I think I thought that what Grant you said about the bits and the chips, I'll just confess, I didn't realize there was so much overlap between computing and geology. So all the bits and the chips having as much signal as that was more puns. I don't know why I'm making puns here, but anyway, that there's more overlap between that and the core. That strikes me as just an insanely high return activity for you. In that I would have thought one way I would approach this is just putting aside the current core. How could I collect a ton of data that is of the type, I got the cores, let me just collect a bunch of dust, as you said, or chips or bits, and start building probably actually quite different models than you're used to building, not predictive models, but models that are asking different kinds of questions, like shared embedding models, fusion models, that start to ask the question, what kind of very cheap to collect thing holds 75%, 80% of the information? That would seem to be like a game changer for the entire field of mining. And so given that that seems transformative for the field of mining, I would have been happy to put a ton of resources into just that, because you've now taken the most expensive part of this and dropped 2, 3 zeros out of it while keeping 80, 90% of the information. Like, in other words, what's, is there the equivalent of a stethoscope that substitutes for some much more invasive thing? That would strike me as very, very, very valuable.
I think there is nothing better to finish on than that. First order change to the exploration process. Grant and Jared, thank you both very much for sharing this. It's just such exciting work that you're doing with Geologic, and as Niamh pointed out, also very timely, given what's happening around the world. And Rich, Sendhil, and Niamh, awesome. This was a lot of fun. Thank you so much for your thoughtfulness and creativity in this. And so that's our show for today. Special thanks to all of you. And we'll post the links to our hosts and guest social media feeds and web pages in the show notes, as well as our podcast webpage located online at intrepidgp.com/Derby Mills series. Thanks, everyone, for listening.
Thanks, everyone.
Thank you.
Thanks so much for having us.
The views, opinions, and information expressed in this podcast are those of the hosts and guests and do not necessarily reflect the official policy or position of Intrepid Growth Partners. This content is for informational purposes only and should not be considered as financial, investment, or legal advice.